Hello my dear viewers, you're most welcome and thanks for watching. If you are new to this channel, please kindly subscribe, like, share and comment. So let's now jump into today's video. Tonight we have our lesson 4, and in this lesson 4 we are going to talk of specifically pH and pH scale. pH itself stands for potential of hydrogen, and by definition pH can be defined. So we are saying that definition: pH is the measure of the degree of acidity or alkalinity of any given substance, of a substance. And this substance can be a solution, can be aqueous, can be in molten state. So long as we have determined the degree of acidity, its acidity or alkalinity, then there we have determined what we call the pH. Or still somebody can define pH as is the negative logarithm to base 10 of the molar concentration of hydrogen ions, i.e. we always have that pH is equal to the negative logarithm to base 10 of the molar concentration of hydrogen ions. That is how we could determine the pH. And by definition, we already say that is the degree or is the measure of the degree of acidity or alkalinity of a given substance. What we have to know is that when you're talking of pH, there are majorly two ions that are responsible for that in solution. So we are going to talk of these two ions in details. First and foremost, this side we are going to talk of the hydrogen ions, and then the other side we are going to talk of the hydroxide ions, or somebody can call them hydroxyl ions. So they mean the same, either hydroxide ions or hydroxyl ions. And these ones, they are written as the capital H, then a charge of +1, whereas the hydroxide ions are written like this, the OH with a negative charge. We see that the hydrogen ions are positively charged, whereas the hydroxide ions are negatively charged. So when we are talking about acidity, basing on these ions present, we have three conditions in here. And the first condition, we are having a neutral solution. So the first one, we are saying that we are having a neutral solution. They have pH of 7, i.e. we can say that pH of a neutral solution equals to 7. And what does it mean? It implies that for us to have a neutral solution, that the concentration of the hydrogen, in the bracket we say they are written like this, ions, is exactly equal to the concentration of the hydroxide ions. In the bracket we say there the OH with a negative charge. So when we have a solution whereby the concentration of hydrogen ions are equal to the concentration of hydrogen ions, then the pH of that solution is neutral or is at 7. We can say i.e. the molar concentration of hydrogen ions of a neutral solution equals to the molar concentration of hydroxide ions. So for us to have what we call a neutral solution. Alright, then we have also the second condition, and we are saying that acidic solutions have a pH which is less than 7, i.e. we can say that the pH of acidic solutions is always less than 7, or we can say pH of acidic solution is less than 7. And this one, it implies that acidic solutions have the concentration of hydrogen ions more than the concentration of hydroxide ions. I can say in bracket or IE, we are saying that the molar concentration of hydrogen ions is greater than the molar concentration of hydroxide ions for us to have the pH of a certain given solution being acidic. Then still the second situation or condition is when we are having an alkaline solution. And alkaline solutions have a pH which is greater. So I say which is greater than 7, i.e. the pH of an alkaline solution is always greater than 7, as you are going to see on the pH scale. And here, for the case of alkaline or basic solutions, so we are having that we say that if not alkaline solution, they are also as well called basic solutions. And in basic solutions or alkaline solutions, we are saying that the concentration or the molar concentration of hydrogen ions is less than the concentration of hydroxide ions, i.e. we can say that the molar concentration of hydrogen ions is less than the concentration of the hydroxide ions. And we are saying that when given these two solutions, for example, the acidic solution, when you are given the acidic solution and the alkaline solution, and on one of them separately, we are adding distilled water. So let's see what happens in the case we are adding distilled water. We are saying that when distilled water is added to an acidic solution, the pH will increase towards 7, or towards pH equaling to 7. Whereas if still we add, we say that when distilled water is added to an alkaline substance or solution, the pH will decrease towards still 7, or pH equaling to 7. So the pH will decrease towards neutral. Let's now talk of the pH scale. Simply, the pH scale is the scale of range of numbers from 0, in bracket 0 to 14. As we can see down here, we have this the pH scale. We are saying it has numbers ranging from 0, and this is our 0 here, ranging from 0 here to 14. And we are saying that the values which are below 7 indicates acidity, or that that substance is acidic in nature, whereas the value 7 indicates the neutrality, or indicates that the solution is neutral, or that substance is neutral. Whereas above 7, then we consider that substance, or such a substance, to be alkali or alkaline. And we have a range of these colors, meaning that in the next lesson we shall talk of the indicators. So when having used the indicator, when testing for the pH or determining a pH, we so much based on the color changes, and then we compare the color change with the corresponding colors indicated on this pH scale. So this is the pH scale, which is indicating the colors and also the pH values, which are run from 0 to 14. Still, we can have this, and here we are saying that in here indicates that the substance is neutral at 7, exactly at 7 here. Whereas below 7, this side indicates acidity. And we are seeing that if it ranges from 3 or from 6 to 3, then we consider that substance to be a weak acid, or acidity, its acidity would be low. Whereas from this range in between 2 and 3 to 0, then that substance is strongly acidic in nature. And we are seeing that as we move from 7 towards the 0, this side, then the degree of acidity increases. That's why by this arrow it shows that the degree of acidity increases in this very direction. On the other hand, we are seeing this another arrow pointing this side, and this means that from 7, where it is the reference point for the neutral solution, as you are moving from it to 14, the degree of alkalinity increases, whereby in between 7 and 11, the substance is weakly alkaline or basic in nature. And then between 11 and 12 to 14, then we consider that substance to be a strong alkaline substance. And thanks for watching. See you in the next lesson.